This is the new style Kinyon hammer that was just completed. It actually works quite well, and I'd like to thank Ron Kinyon for doing the work and designing it, and Paul Branch for making the plans available. I varied a little bit from Ron's plans in that I changed the sow block, or actually added a sow block, and that made welding and aligning the dies much easier. So the anvil is a piece of 8-inch solid stock. The sow block's I think about 7.5 by roughly 3 inches. So the other change we made is in the bottom of the top. Ron called for a 6 by 6 by 1.5 inch plate, and I used a 6.5 by 3.5 inch round, which added additional weight to the top itself. The top with the die is probably about 88 or 90 pounds overall. We used a 10 by 2.5 air cylinder, and that seems to work adequately. One of the other changes that I made on this hammer was the way the top is held in place. And Ron's plans called for a piece of UHMW between the inner wall and the top itself. Well, we did that, but my concern was of aligning the dies, and I'll show you what we did is to mount a piece of UHMW on a 3/4 or 3/8 inch plate, and you can see it's held in with an epoxy as well as physically, so that can't move. What I did do was to index the bolts. The upper and lower bolts on this are the index bolts. The horizontal bolts are to keep the plate itself in line, so there's no oscillation at all with the top. So that's the major change. The hammer itself is about 6 feet tall, and it's on a base of 1.5 inch plate that is 18 by 36. So it's fairly compact. I haven't figured the overall weight of it yet, but it seems to work pretty well the way it is. We used all the valving that Ron specified, and that works wonderfully. The only thing I didn't do with the valving was to use the check valves on the foot treadle. I didn't find that they were necessary on the 2 exhaust valves. So it would be this one right here. The middle one is a check valve coming in on the main air line, and then this one we eliminated those 2 check valves. And we found that didn't really make any difference, plus it saved us some money. So this is about what it looks like. We did make our own spring on the top. Paul Branch's plans called for ordering a spring, but we made our own because we're hard-headed. And we used a 2.5 by 3/8 inch spring. I think if I were to do this again, I might drop it down to maybe 5/16 by 2.5. It might give it a little bit more whip. Also on Ron's hammer, the distance between the center of the top where it's attached and the spring itself, he runs about 4 inches in here, and I'm a little bit greater than that. I'm probably close to 6 anyhow. But I don't know the ins and outs of it, but it works like it is, and so that's as good as it gets. So anyhow, this is the hammer, and I'm going to fire up the forge and show you what it'll do on some 1-inch square stock, and all in all, it's a really nice hammer. I think if I were to make a change in this, in another hammer, I would probably go to some sort of a roller bearing, a linear roller bearing in place of the UHMW. I think the UHMW actually impedes a little bit of the speed because it's necessary to keep pressure against the top to keep it aligned. So I think I'd probably go with some sort of a linear bearing, probably just a plain linear bearing on maybe a 1 inch on either side, on maybe a 1 or 1 1/4 inch shaft would be adequate. So that's the only change I'd make, and other than that, this thing works great. We'll show you what it's all about. Okay, I've got a piece of 1-inch round stock ready to go. here's what it is. Really impresses me about this air hammer is that the amount of control it has. It's running at about 100 pounds of air pressure, but you know, you can feather it right down to it. That's probably about 3/16 of an inch.